Security is paramount in back-end development, where sensitive data and critical systems are often managed. Understanding common security threats and vulnerabilities is essential for building robust and secure back-end applications. This section explores some of the most prevalent threats and vulnerabilities encountered in back-end development and discusses strategies for mitigating these risks. Injection attacks. Injection attacks, such as SQL injection and NoSQL injection, are among the most common and dangerous vulnerabilities in back-end systems. Attackers exploit input validation weaknesses to inject malicious code into queries or commands processed by the back-end database. This can lead to unauthorized access to sensitive data, data manipulation, or even complete database compromise. To prevent injection attacks, developers should use parameterized queries, input validation, and proper escaping of user input. Cross-site scripting, XSS. Cross-site scripting, XSS, vulnerabilities occur when attackers inject malicious scripts into web pages viewed by other users. These scripts execute within the context of the user's browser, allowing attackers to steal session cookies, perform unauthorized actions, or deface the website. To mitigate XSS vulnerabilities, developers should implement output encoding and sanitize user-generated content to prevent script injection. Content Security Policy, CSP, headers can also help mitigate the impact of XSS attacks by restricting the execution of inline scripts and external resources. Cross-site request forgery, CSRF. Cross-site request forgery, CSRF, exploits the trust of authenticated users to perform unauthorized actions on their behalf. Attackers trick victims into unwittingly submitting malicious requests, such as transferring funds or changing account settings, by embedding crafted requests in legitimate websites or emails. To prevent CSRF attacks, developers should implement anti-CSRF tokens, validate the origin and referrer headers, and use techniques like same-site cookies to mitigate the risk of unauthorized requests originating from other domains. Authentication and session management flaws. Weaknesses in authentication mechanisms and session management can lead to unauthorized access and account compromise. Common vulnerabilities include weak passwords, predictable session identifiers, and improper handling of authentication tokens. Developers should enforce strong password policies, implement multi-factor authentication, MFA, and securely store and manage session tokens to prevent unauthorized access and session hijacking. Insecure direct object references. Insecure direct object references occur when attackers manipulate input parameters to access unauthorized resources or sensitive data directly. This can occur when backend systems expose internal identifiers, such as database keys or file paths, in client-facing requests without proper authorization checks. To mitigate IDE vulnerabilities, developers should implement access controls and authorization checks at the server side to validate user requests and ensure they have appropriate permissions to access the requested resources. Insecure deserialization. Insecure deserialization vulnerabilities arise when attackers manipulate serialized data to execute arbitrary code or perform unauthorized actions on the server. This can lead to remote code execution, RCE, denial of service, DOS, or data tampering. To mitigate insecure deserialization vulnerabilities, developers should validate and sanitize serialized input, restrict the types of objects that can be deserialized, and implement integrity checks to detect tampering or unauthorized modifications. Secure coding practices are essential for building robust and resilient backend applications that can withstand malicious attacks and protect sensitive data. This section explores key principles and techniques for implementing secure coding practices in backend development. Input validation and sanitization. One of the fundamental principles of secure coding is input validation and sanitization. All user inputs, including form data, query parameters, and HTTP headers, should be validated and sanitized to prevent injection attacks such as SQL injection, NoSQL injection, and cross-site scripting, XSS. Developers should use parameterized queries for database interactions, validate input length and format, and sanitize user-generated content to remove or encode special characters that could be interpreted as malicious. Output encoding. Output encoding is crucial for preventing cross-site scripting, XSS vulnerabilities, which occur when attackers inject malicious scripts into web pages viewed by other users. Developers should encode user-generated content before rendering it in HTML, JavaScript, CSS, or other output contexts to prevent script execution. Frameworks and libraries often provide built-in functions or middleware for automatic output encoding, but developers should also be aware of manual encoding techniques when necessary. Authentication and authorization. Proper authentication and authorization mechanisms are essential for controlling access to back-end resources and protecting sensitive data. Developers should implement strong password hashing algorithms, enforce password complexity requirements, and use secure session management techniques to prevent session fixation and session hijacking attacks. Role-based access control, RBAC, and attribute-based access control, ABAC, can be used to enforce fine-grained access controls based on user roles, permissions, and attributes. Secure communication. Secure communication between clients and servers is critical for protecting data privacy and integrity. Developers should use secure protocols such as HTTPS TLS to encrypt data in transit and prevent eavesdropping, tampering, and man-in-the-middle attacks. They should also ensure that SSL TLS certificates are properly configured, validated, and renewed to prevent certificate-related vulnerabilities and ensure the authenticity of the server. Error handling and logging. Effective error handling and logging are essential for detecting and responding to security incidents and vulnerabilities. Developers should implement comprehensive error handling mechanisms to gracefully handle unexpected conditions and prevent information leakage that could aid attackers. Additionally, logging security-relevant events and exceptions can provide valuable insights into the application's behavior and help identify and mitigate security vulnerabilities proactively. Secure configuration management. Secure configuration management involves hardening servers, databases, and other infrastructure components to minimize their attack surface and reduce the risk of exploitation. Developers should follow industry best practices and security guidelines for configuring operating systems, web servers, databases, and third-party dependencies. This includes disabling unnecessary services, applying security patches promptly, and configuring firewalls and intrusion detection prevention systems to monitor and block suspicious activity. Secure third-party integration. Third-party libraries, frameworks, and APIs can introduce security risks if not used and configured correctly. Developers should carefully evaluate the security posture of third-party components, including their track record for security vulnerabilities and the availability of security patches and updates. Additionally, they should adhere to the principle of least privilege when integrating with third-party services and minimize the exposure of sensitive data and credentials. Data encryption and hashing are crucial techniques used in back-end development to protect sensitive information, ensure data integrity, and mitigate the risk of unauthorized access and data breaches. This section explores the concepts of data encryption and hashing, their importance in back-end applications, and best practices for their implementation. Introduction to data encryption. Data encryption is the process of converting plain text data into ciphertext using an encryption algorithm and a cryptographic key. The ciphertext can only be decrypted back to plain text using the corresponding decryption key, ensuring that the data remains confidential and secure from unauthorized access. Encryption algorithms vary in complexity and strength, with modern algorithms such as AES, Advanced Encryption Standard, and RSA, Riv Shamir Adleman, being widely used in back-end applications. Importance of data encryption. Data encryption plays a vital role in safeguarding sensitive information such as user credentials, payment details, personal identification information, and confidential business data. By encrypting data at rest, stored data, and data in transit, transmitted over networks, back-end developers can prevent unauthorized access, data leakage, and interception attacks. Encryption also helps organizations comply with data protection regulations and industry standards, such as GDPR, General Data Protection Regulation, and PCI DSS, Payment Card Industry Data Security Standard. Common encryption techniques. There are two primary types of encryption techniques used in back-end development: symmetric encryption and asymmetric encryption. Symmetric encryption uses a single shared key for both encryption and decryption operations. It is efficient for encrypting large amounts of data and is commonly used for securing data at rest. Asymmetric encryption uses a pair of public and private keys for encryption and decryption. respectively. It provides enhanced security by allowing data to be encrypted with the public key and decrypted with the private key. Hashing is a one-way cryptographic function that converts input data, plain text, into a fixed-size hash value, digest, using a hashing algorithm such as SHA-256, secure hash algorithm, 256-bit. Unlike encryption, hashing is irreversible, meaning that the original plaintext cannot be derived from the hash value. Hashing is commonly used for storing passwords securely, generating checksums for data integrity verification, and creating digital signatures. Importance of hashing. Hashing is essential for ensuring data integrity, authenticity, and non-repudiation in backend applications. By comparing hash values, developers can verify that data has not been tampered with or corrupted during transmission or storage. Hashing is also widely used in password storage, where hashed passwords are stored instead of plain-text passwords to prevent exposure in the event of a data breach. Best practices for data encryption and hashing. Use strong encryption algorithms. Choose modern encryption algorithms with strong cryptographic properties, such as AES for symmetric encryption and RSA for asymmetric encryption. Implement key management practices. Securely manage encryption keys using industry-standard key management practices, such as key rotation, key storage, and key access controls. Salted hashing for password storage. Use salted hashing techniques to securely store user passwords by adding a random salt value to each password before hashing it. Secure transport layer encryption. Implement HTTPS TLS encryption to protect data transmitted over networks and prevent eavesdropping, tampering, and man-in-the-middle attacks. Regularly update encryption libraries. Keep encryption libraries and dependencies up to date with the latest security patches and updates to address known vulnerabilities and weaknesses. Cross-site scripting, XSS, and cross-site request forgery, CSRF, are two prevalent security vulnerabilities that can compromise the integrity and security of web applications. Understanding these vulnerabilities, their impact, and how to mitigate them is crucial for backend developers. This section delves deeper into XSS and CSRF, their implications, common attack scenarios, and best practices for prevention. Cross-site scripting, XSS. It is a type of security vulnerability that allows attackers to inject malicious scripts into web pages viewed by other users. These scripts execute within the context of the victim's browser, enabling attackers to steal sensitive information, hijack user sessions, deface websites, or launch further attacks. XSS vulnerabilities typically arise from insufficient input validation and output encoding, allowing attackers to inject malicious code into user input fields, URLs, or other vulnerable parts of web applications. Types of XSS: reflected XSS and stored XSS. Impact of XSS includes data theft, session hijacking, defacement, and malware distribution. Mitigation strategies for XSS include input validation, output encoding, content security policy (CSP), and web application firewalls (WAFs). Cross-site request forgery (CSRF). CSRF is a security vulnerability that allows attackers to execute unauthorized actions on behalf of authenticated users. Impact of CSRF includes unauthorized actions, data manipulation, and account takeover. Mitigation strategies for CSRF include anti-CSRF tokens, same-site cookies, referrer header checks, and CSRF protection libraries. See you soon.